Hi everyone, in this video I'm going to talk a little bit more about the line of best fit. Then you're going to watch this, take notes, and send a picture of your notes that are on a separate sheet of paper for credit. Now, the reason why this says my current mood is super happy is because this is the last assignment and that's it. So all of the work is due on June 9th. So if you haven't done all the stuff on Castle Learning or there were things that you never sent to me, you can still do it, right? And then you are done. So let's get into this last thing of notes. And as always, please text or email me if you have any questions at all. Okay, so the learning targets, we need to use the calculator to find the line of best fit. We've already done that. You need to use the equation to make a prediction. We've done that too. This last thing is new. You're going to use the calculator to find the correlation coefficient. So that's a specific letter and that's called R. Here are some examples that we've already talked about with the correlation coefficient. It could be positive or negative depending on which direction the trend is going. It could have no correlation or strong, moderate, or weak correlation. So this first one is strong because the points are very, very close to the line of best fit. It's positive because the trend line is in a positive increasing direction, and an R value of 0.9. So remember, if the R, which is this number here, is very, very close to +1, it's strong and positive. If this was negative, this would be very strong, but it would be a negative correlation. All right, and that's what we're going to get into today, and the calculator is going to calculate this R value for us. Okay, so before we've taken some data, we plugged it into the calculator, and then we used the linear regression command. We're going to do the same thing, but there's one thing we need to turn on, and that is our stat or our statistics diagnostics. So we're going to go through this question number 1 like normal, except when we go to linreg, we're going to have to turn something on first. All right, so first step, we have to plug in our data. So we're going to go to stat, edit, and then you're going to plug in everything. I already did just to save some time. So I took these points and put them in for my X, which is my list 1, and these for my Y, which is list 2. All right. Now we're going to turn the diagnostics on. That's that new step. So all I need to do is go to mode, which is right next to the second button. And then you need to look for stat diagnostics. It's right here. And notice how it says on. It's only on because I just did it, but it would be off. And if it was off, the off would be highlighted, like bolded. So click enter on and make sure that is turned on. Now we can go through this like normal, get our linear regression equation by pressing stat and then go to the right for calc because we need to calculate the line of best fit. Number 4 is that linear regression line, which is the same thing as the line of best fit. Notice it's ax plus b. That's the same thing as mx plus b. All right, there we have list 1, list 2. Nothing in our frequency list. We could store our y1 function. So let's do that. We're going to press vars for variables, yvars, go to the right, enter on function, enter on y1. If you do that step, you'll get the line on your scatter plot. If you don't, you won't get the line. So let's make sure we get the line. And then calculate. All right, so here we have a little bit extra information here. We have r squared and r. Before today, there was nothing here because that stat diagnostics was turned off. So you didn't get that info. But now it's on, and we want r, not r squared, only r. All right, so we used our calculator. We need to create a scatter plot. We'll use a calculator for that. But first, B, state the equation of the line of best fit, round to the nearest hundredth. Okay, so I already did that. That's just taking the values from the calculator, right? A and B, plugging them in for A and B, and then you have the line. Next, state the value of the correlation coefficient, which we now know is R. So instead of always saying correlation coefficient, that's a very long 2 words there, you could just say R. And that's going to be 4 decimal places. So here it is, 9824. Boom. And let's get the scatter plot, and then I want to say something else about C. All right, so if we're on our calculator, you need to press zoom stat so we get our zoomed in picture of our scatter plot. Voila, there we have it. And the line of best fit is on the graph. It looks beautiful. I'm going to put this on the paper. Make sure that you copy down this graph. And look at that. All of these points, those are right in this graph here. All right, now let's talk about the correlation coefficient. This R value and this graph, they go together. Okay, this blue line right here, y equals mx plus b, this is that blue line right there. And these green dots are all of these points, 932, 1337. Okay, so it's just a different way to represent the data. Okay, so this picture, if we go back, not to that, but to this. Okay, which one of these does that look like? All right, not that close to this one because the dots are all over, but look, it looks similar to the first one there. Okay, so this is positive because it's going in a positive direction. It's strong because the points are very close to the line. And this red picture over here, the R is 0.9, and our R is 0.9824, right? So let's say something about the correlation. So the closer the R is to 1 or -1, the stronger the correlation. This is a very strong positive relationship because this number is positive, this graph is going in the positive direction, and the R is very close to 1. If it was close to -1, it would just be a strong negative correlation. Okay, here we go. This is our next example. So the table below summarizes the high temperature of several days and the number of golfers at a local course. So this could be Hyde Park. So your X is your temperature. So make sure that you label, like I want you to copy down this table here and make sure you label temperature is X and number of golfers is Y. They give you the equation of the line of best fit, but you could have found that using the calculator too. So A, it says, predict the number of golfers on a day where the high temperature reaches 75 degrees. So first thing that I did was label my X and my Y. So golfers is Y and the temperature is X. So we are missing the Y, so that's just what we're going to solve for. So use this equation here, plug in your temperature for X, and solve for Y. All right, so here it is. Make sure you use your decimal point there for 0.82, plug in your 75, subtract 4.07, and you get 57.43. So if you rounded that, it would be about 57 golfers. So if the temperature that day was 75 degrees, there should be around 57 golfers on the course. Next up for B, predict the temperature. So that's our X. If you know that 65 golfers use the course. So that's your Y, the 65 golfers. So this time you're going to plug in your 65 for Y and you're going to solve for X because we don't know the temperature. All right, so this top line here, that's me plugging in 65. First step was to add 4.07 to both sides. Then you're going to divide by 0.82. You get 84.23, which rounds to be about 84 degrees. Okay, so if there were 65 golfers on the course, the temperature should be about 84 degrees. Last but not least, predict the number of golfers if the temperature drops to 50. So we know the temperature. This is just like A. We knew it was 75. Here we know it's 50. We don't know the number of golfers, so we don't know why. So you take your 50, plug it in, and then you get out 36.93. And then we just need to round that. You could have put 36 golfers or 37, just as long as it was one of those numbers, you'd be fine. For people, we don't necessarily round like up because 0.93 is not a whole person, but this line right here is an estimate in of itself. So it could be 37 golfers. All right, so that about wraps it up for this video. All you need to do is send me a picture of your notes and you are done. But if you didn't do any of the work from before, or there's one thing you want to still turn in, you still can. You have till June 9th. All right, so have a great day.